Okay, so let us now proceed to rational exponents. So the key thing that you have to remember here is this principle right here. The nth root of a is equal to a raised to 1 over n. Okay, so to give you an intuitive idea of why this works, let's give an example here. So say we have 4 raised to x is equal to 2. Okay, so we want to find the exponent x such that if we raise 4 to x, we get 2. Okay? So how do we work this out? So let's square both sides. It's equal to 2 is to 2. Okay, so we then get 4 raised to 2x is equal to 4. Now since they are equal and they have the same base, therefore their exponents should also be equal. Okay? So as you know, the exponent of 4 is 1. And then they have right here 2x is equal to 1. Therefore, x is equal to 1 over 2. Okay? So that's exactly what you have here. So that is how that works. Okay, so we also have here the nth root of a raised to m is equal to a raised to 1 over n as we discussed earlier, and then raised to m, which is equal to a raised to n over n. Okay. So this is also equal to this particular expression right here. The nth root of a raised to m is equal to a raised to m raised to 1 minus n. So from the law of exponents, we just multiply these two, and then we get the same result. So therefore, these are the same. Okay? So let's apply these two examples. Okay? So say we have here the square root of 3. So let's remove this now. It's already understood. So the square root of 3. So we know that the index is 2, right? So we have here, this is therefore equal to 1, 3 raised to 1 half. Okay? Okay, let's proceed to the next one. We have here the square root of 3xy raised to 5. Okay, so what principle are we applying here? We are applying this one, right? We have here the principle a raised to m square root of n is equal to a raised to m over n. So you will have 3xy raised to 5 over 2. Okay. So let's proceed to the next one. We have here, so we can also rewrite this as 2x times x raised to 3 over 4, right? And then, if we evaluate that using the law of exponents, we can then get x times 1 plus 3 over 4. Then this will be equal to 2 times x raised to 7 over 4. Okay. So now let's proceed to second set of examples, exponential to radical. Okay. We have here x squared plus y squared is raised to 3 over 2. So what do we know? So this is equal to x squared plus y squared, and then raised to m. Raised to, 3, right? Raised to 3, right? And then from this, we know that they are equal. These two are equal. So we can then also rewrite this as x squared plus x squared plus y squared cube, and then put the radical symbol, square root. Okay, so we have here, that's our final answer. Okay, so we have here, the next one, we have a raised to negative 3 over 2. So what does this mean when you have a negative exponent? We have here 1 over a raised to negative 3 over 2. 2. 3 is already 3 over 2, right? Okay, so we can then express this as, so 3 over 2. So this is square root of a cubed. Okay. So for the last one, we have here x raised to 0.2. So We know that 0.2 is also equal to 1 over 5. So we can write this as x raised to 1 over 5. And then we can then finally write this as the fifth root of x. Okay, so that's it. Let's continue with more examples in the next video.